In this module, we are going to discuss the problems which are given in the exercise 1.3 of real number chapters. Okay. Before starting that, better to recall two definitions. Already you learn about this. One is rational number. Come on, recall and check whether your answer is same of this or not. And now the other question to you is, give some examples of rational number, at least one. Post after watching this video in the comment box. Next, irrational number. Yes, a number which cannot be expressed in the form of p by q is called an irrational number. Come on, give some example of irrational number. Okay, pi. We use this one in the mensuration in some formula. Is it rational or irrational? Come on, let me know. Whatever the answer you give reason also. Post that in the comment box. Okay, now move to the exercise. Here the question is, prove that root 5 is an irrational number. Root 5 is an irrational. To prove this one, we have to start from its contrary. So contrary means, see here. Let us assume that this root 5 as rational. We have to prove it is irrational. But we are starting with as rational. Following the definition of rational, root 5 is equal to what? A by b, fraction form, where a and b are integers, right? And 2 points you need to remember while taking those integers. What that? A and b must not have common factors other than 1. So such numbers are called coprime. Coprime is nothing but the pair of numbers which has only one common factor, that is 1. And b is non-zero because it is in the denominator, no? Yes. Now squaring on both sides this equation, we'll get the expression like this. Root 5 whole square is equal to a by b whole square. Next, by finding the squares, for the root and square we will get cancelled. 5 remain here. A square by b square. By simplification, finally what we get? 5b square is equal to a square. Here a square is equalized to 5 into b square. So a square is divisible by 5 or not? Because here 5 is there, no. Suppose here 7 is there, divisible by 7. But in this equation, a square is divisible by 5. If the a square is divisible by 5, then the main factor a also divisible by 5. So this expression is taken as equation 1. Now finally, from this equation 1 we conclude a is divisible by 5. Now we take a, or we express a in the general format of multiple of 5. That is, a is equal to 5k because it is divisible by 5 now. So here k is some integer. Again, we find the square of both the side terms. And here what we'll get? A square is equal to 25k square. In the first equation, a square is equal to what, ma? 5b square, no. So in the place of a square, we write this expression. Yes. Then see, 5b square is equal to 25k square. By simplification, 5 ones, 5 5s. Then finally, b square is equal to 5k square. Here, square of b equals to 5 into k square. Means, like a square, b square is also divisible by 5. If b square is divisible by 5, then b also divisible by 5, no? Yes, that's why this you take this one as a second. From the first and second equation, what we can understand? A is divisible by 5, b is divisible by 5. Means A and B have 5 as a common factor. These two equation states A and B have a common factor 5. But it is opposite to our assumption now. What we assume, root 5 is a rational, that is A by B. A and B have only one common factor, that is 1. But here what we got? A and B have another common factor 5. So it is a contradiction to our assumption. Means opposite to our assumption. What we thought, what we assume, root 5 is rational. But it is the opposite no. So then finally what we can conclude? Root 5 is an irrational number. That's clear. Like that you need to verify. So here we write this equation 2, 1 and 2, and these statements are written following